Welcome back to Algebra 1 with Miss Betsy. Today we are in section 3.6 of our text, and we're talking about removing parentheses. And this is not just to simply help us to understand order of operation, but we're going to be seeing how we use the distributive property to remove parentheses prior to collecting like terms. I'm using as my text Algebra 1 for Christian schools. It's the second edition. Looks like this. We are in section 3.6 on page 103. Even if you don't have the same text that I do, you can still learn from this video. So let's go ahead and pray, and then I've got another, let me see which one I'm going to do. Oh, another awful lame joke. Father, I thank you that you are constant. And even as I pray that, I think of the math pun that's involved there. You know, we've talked about constants and variables, and Lord, that you do not vary, you do not change, but that you are always constant. And I thank you for that. I ask, Lord, that you would help us to learn what you would have us to learn today, that you would help us to be diligent and disciplined in all that we do, and that we would glorify you today in our lives. In the name of Jesus I pray. Amen. Okay, why is it that teddy bears are never hungry? Surely you know this one. Teddy bears are never hungry because they're always stuffed. Removing parentheses. Let me read this from you. My apologies to those of you who despise being read to, and I'm one of those, and I'm reading to myself. An algebraic expression enclosed in parentheses, braces, or brackets is treated as one term. And we've talked about that a lot when we substitute in. I said you've got to put parentheses around your substitution. Make sure that it travels together. That means it's treated as one term. For example, the quantity 2x plus 5 is considered as one term. Let me erase this from the previous video. The quantity 2x plus 5 is considered as one term as opposed to 2x plus 5. Remember I said that the way you tell terms is if they're separated by an addition sign or a subtraction sign. So here we have two terms, 2x plus 5. Here, however, we just have one term. Even though the 2x and the 5 are separated by an addition symbol, the parentheses overrides that general rule and says treat all of this together. So this is one term, and you've heard me use this terminology all year long. This is read the quantity 2x plus 5. When you get to your first parenthesis, you call that the quantity 2x plus 5. Okay. If a number comes before the parentheses indicating multiplication, you remove the parentheses by using the distributive property. So if we have 4 times the quantity 2x plus 5, we're going to remove them using the distributive property. And you remember that the distributive property says if you have something that looks like a times the quantity b plus c, that becomes a times b plus, not a times b again, but a times c. What you do is you take the number outside the parentheses and you multiply it with each term inside the parentheses. So 4 times the quantity 2x plus 5 is going to be 4 times 2x plus 4 times 5. 4 times 2x, 4 times 2 is 8, x plus 20. So this is what we're going to be doing with removing parentheses. So let me look at example 1, which is very similar to this, 4 times a plus 3b. 4 times A plus 3B. We take our factor on the outside, multiply it against each term inside the parentheses. 4 times 3B. 4 times A is 4A, plus 4 times 3 is 12B. This should be continued review for you, but you will use the distributive property constantly in every math class from here on out. So make sure that you are competent in applying that, particularly when you have negative numbers. So a negative number here would be example 2 on page 103. Negative 2 times the quantity 3x squared minus 4x plus 5. Remember, we said with terms with factors in algebra, the sign in front travels along with the number. So we're going to have negative 2 times 3x squared. Now, we actually have here negative 2 times a negative 4x. So how do I want to write that for you? We're going to say that our distributive property that I inadvertently erased, we're going to use the exact pattern over here, AB plus AC. A, so it's going to be plus A times B, negative 2 times a negative 4x, plus a negative 2 times a positive 5. Our multiplied, our products of our pairs of factors are separated with an addition sign. Negative 2 times 3x squared plus negative 2 times a negative 4x plus negative 2 times a positive 5. We multiply these out. This is the associative property that lets us multiply negative 2 times 3 is a negative 6x squared plus negative 2 times negative 4 is a positive 8x plus negative 2 times 10 is a negative 10. We don't leave plus a negative in our final answer. We have negative 6x squared plus 8x minus 10 is the solution to negative 2 times the quantity 3x squared minus 4x plus 5. And I turned over one page too many. Or turned my book down upside down. I'm not quite sure what I did. Negative 6x squared plus 8x minus 10. And if you looked here, the signs inside the parentheses reversed. You had a positive, became a negative. A negative became a positive. Positive became a negative again. They reverse because you're multiplying by a negative number. Now, example 2. I'm sorry, example 3. My glasses are giving me fits today. The quantity 2x plus 5 plus the quantity 3x minus 9. Nothing special going on here. No multipliers, no negatives. 2x plus 5 plus 3x minus 9. What do we have for like terms? We have the x's, and then we have the constant terms. How do we add 2x plus 3x? We add the coefficients. 2 plus 3 is 5. And we keep the variable. How do we add our constant terms? Just like you add numbers. Plus 5 minus 9 is a negative 4. And that's all that's involved in example number 3. Now let's see what we have for example number 4. Right here we have the quantity 5x minus 7 minus the quantity x minus 6. Now I want you to follow closely what we're doing here, because we're going to see here, we're going to multiply by a negative 1. You don't see that 1. The coefficient is understood to be a 1. And we just saw in our prior example that when you multiply by a negative, the signs within those parentheses reverse. Nothing multiplying 5x minus 7, so we simply have 5x minus 7. We're multiplying by a negative, but it's just a negative 1. So that means simply that the signs in front of the terms within our parentheses here are going to reverse. Negative 1 times x is a negative 1x. Negative 1 times the negative 6 gives us a positive 6. We now have like terms. 5x minus x is 4x. Negative 7 plus 6 is a negative 1. And our solution then is 4x minus 1. Okay? Example 5 and example 6 and example 7 and example 8. This is a long set of examples. I want to work through them. Even though I ask you to read these, I want to work through them and talk you through them so that you can gain from them. Now we have example 5. 4a times the quantity a plus b plus 3 times the quantity a squared plus 2. And I want to check and make sure that this is the example we have in your book, even though I could just make up a problem and it would still work. 4a times a plus b, 3 times a squared plus 2. First off, I'm looking here and I see no negative signs, and that makes me happy because negative signs cause problems for us all the time. I drop negative signs, everybody's going to drop a negative sign at some point. So when you don't have to worry about negatives, it's nice. We're going to okay, oh, that's different. There's a letter outside. No big deal. We're just going to take the outside and multiply it with the inside, so that becomes 4a times a plus 4a times b. Same thing here. We're going to multiply that 3 against both of these terms with inside the parentheses. 3 times a squared plus 3 times 2. And you see some of these I enclosed in parentheses, some I didn't. That's just particularly messy. 3 times a squared. It's not necessary to put that extra parentheses there because there's no way that you can misunderstand what's being said. 4a times a. What's a times a? Remember, when you multiply variables that are the same base, you add the exponents. That's like saying 4a to the first times a to the first, a to the 1 plus 1, 4a squared plus 4ab plus 3a squared plus 6. And you look at you and you think, ah, how in the world is this more simple than what we have up here? Sometimes your solutions or your simplified form is still going to be something that probably screams at you and says, there's no way this can be the answer, it's just too big and messy. Well, it is big and messy, but in an orderly sort of way. Okay. Interesting. Ha ha! Is it done? Was I careful? 4a squared plus 4ab plus 3a squared. Look at that. We have a pair of like terms. I think in my mind I saw the 3a squared as 3b squared. Look at that. A squared. We have like terms. How do you deal with like terms? You add their coefficients. 4 plus 3 is 7a squared plus 4ab plus 6. So now it's a little bit neater looking. Congratulations to those of you who caught it. To those of you who didn't, teachers do make mistakes. However, and sometimes, even though this was not true, you will have long answers that are as simple as they come, and that there's nothing else that you can do to it, and you think, I've got to have to do something to it. Not necessarily. All right, let's look at example number 6 now. Example number 6 is 2 times 3x squared plus 4x minus 8 times the quantity x squared plus 2x. This time we have the negative sign, beware. So what are we going to do? We're going to multiply 2 times both of these quantities in here, 3x squared, plus 2 times 4x, plus negative 8 times x squared, plus negative 8 times 2x. Now we're going to go ahead and multiply. 2 times 3 is 6x squared. 2 times 4 is 8x plus, what's a negative 8 times x squared? It's a negative 8x squared plus negative 8 times 2 is a negative 16x. Now, plus and negative doesn't work. We're going to change that into subtraction. Six x squared plus 8x minus 8x squared minus 16x. Now, you're going to say, Miss Betsy, could we have honestly left it that way and dealt with combining like terms first? Sure. 6x squared plus the negative 8x squared is going to be negative 2x squared. 8x plus the negative 16x is going to be negative 8x. Or you can think, we have our common fact, our like terms here. 6x squared minus 8x squared. 6 minus 8 is negative 2x squared. 8x, negative 16x. 8 minus 16 is a negative 8x. And hopefully that's going to be the answer that we have in the book. Negative 2x squared minus 8x is exactly what we have. How do we remove parentheses? They review for us. They say first, you apply the distributive property, which is what we've done. Then you combine like terms. That's all that's involved in dealing with parentheses and the distributive property. We have 2 more problems that I would like to illustrate for you. This is just where we get a little bit longer problem, and it says remove the grouping symbols and simplify the expression. And this is going to look ugly at first. Example 7 on page 105. 7x squared minus, bracket, 3x plus 4y times the quantity 2x minus 8y minus 4x, close bracket, plus 5xy. Goodness, isn't that a long problem? Mm-hmm. Should we check it? Oh yeah. Let's see. 7x squared minus bracket 3x plus 4y times 2x minus 8y, close parenthesis, minus 4x, close bracket, plus 5xy. Now, Our order of operation kicks in here. Remember, we work from the inside out. When we have multiple symbols of inclusion, we have brackets, we have parentheses. What we have going on here at the very center is 4y times the quantity 2x minus 8y. So we're going to have to distribute there. Now, how are we going to write this? We're going to start at the left-hand side and we're writing down every single thing we write. 7x squared minus bracket 3x plus. Here's where we're going to use our distributive property. Plus 4y times 2x plus 4y times a negative 8y. Nothing else to distribute, so we continue on. Minus 4x, close bracket, plus 5xy. Now, what are we going to do next? Still, with inside our brackets, we have a couple of pairs of multiplication that we need to do. 7x squared minus bracket 3x plus 4y times 2x. Numbers first. This is 4 times y times 2 times x. The commutative property multiplication says it doesn't matter what order. So we're going to say 4 times 2 is 8. Y times x is x, y. Remember to be careful to put your variables in alphabetical order. Plus 4 times a negative 8 is a negative 32. Plus a negative is the same as saying minus 32, right? Minus 32, y times y is equal to y squared. Make sure that you understand where this came from. Plus 4 times negative 8 would be plus a negative 32. Plus a negative 32 is the same as minus 32. Y times y, we have the same base and the same exponent. The exponent is 1. You add them. 1 plus 1 is 2. Y times y is y squared. Now we have minus 4x plus 5 times x times y. Now we're down to where we have brackets only. We're going to simplify or combine like terms within those brackets. What do we have that's the same? Well, we've got a 3x and we've got a negative 4x. And our brackets are going to go away now. Actually, I'll do one more step and leave them in. 3x squared minus 3 minus 4 is a negative 1, so we have a negative x plus 8xy minus 32y squared plus 5xy. And do you want to know exactly why you had to make certain that you left those brackets in there? You have a negative sign to distribute. Checking and making sure. When you have a negative outside of a grouping symbol, what happens? The sign of every term inside changes because what you're actually doing is multiplying by negative 1. So we have 7x squared. Rather than minus x, it's plus x. Rather than plus 8xy, it's minus 8xy. It's not negative 32, but it's plus 32y squared plus 5xy. See how this problem takes up a lot of space? Paper's cheap. Use the paper and show every single step. If the cost of paper is a problem, come see me and I'll give you a stack of paper. Now, now we have some squares, and we have different squares, and we have some combinations of variables. Okay, let me glance right here. Okay. When you have different variables squared, what you're going to do is pick one of those, and it's the one that comes first in the alphabet. X is before y. So we're going to start with the highest power of x. It's going to give us 7x squared. I've already used that term. I'm going to use this as an aid to make sure that I don't miss a term. Once I use the x squared, I'm going to go down. Just look for x. Well, here I have x all by itself, so I have plus x. There are no more single terms out there that have just an x. So now we're going to pick up our xy. We have negative 8xy, positive 5xy. So our variables together, the x and y, that's what makes the like term. Negative 8 plus 5 is a negative 3xy. I'm going to slash those out. And we have that 32y squared hanging there all by its lonesome. 32y squared. This should be exactly the solution to our problem. 7x squared plus x minus 3xy plus 32y squared. This might look, probably does look at you go, bleh, looks awful hard. Take it a step at a time, a bite at a time. That's like, how do you eat an elephant? Well, you eat an elephant one bite at a time. You take this problem here, one bite at a time. You might even want to add extra steps in here that I combined together. But this is how we simplify this expression. One final one that I want to do for you involves negatives again. And you notice how a lot of our problems have negatives in them. That's because they show up a lot, and it's also because that's what's most apt to trip you up, is how do you deal with the negative signs. The problem says to remove parentheses and simplify the expression. We're going to have 3k times the quantity, k plus 2, minus k times the quantity, k minus 1. We're multiplying by a variable, which is just fine. And here we're multiplying by a negative. We use the distributive property first. 3k times k plus 3k times 2. I'm going to multiply this plus a negative k times k plus a negative k times a negative 1. All right? K times k is k squared. We have 3k squared plus 3 times k times 2. You change that order around so that you multiply your numbers together first. 2 times 3 is 6k plus, what is k times k? It's k squared. But we have a negative, so this becomes a negative k squared. Plus negative k times a negative 1. A pair of negative factors is always positive. Negative k times a negative 1 is a positive k. So, how can we simplify like terms here? We have k squared, k, and k. So we have two pairs of like terms. 3k squared plus a negative k squared, 3 plus a negative 1 is a negative 2k squared plus 6k times 1k is 7k. Make certain that you understand how you arrived at this solution. That's because you're going to be tempted to forget about that k squared, that negative k squared there, because you don't see a coefficient. You're going to be tempted to say that's a negative 3 squared, a negative 3k squared. You're going to be tempted to not see that k because it doesn't have a visible coefficient. You're going to be tempted to say 6k instead of 7k. But now, since we've gone through that, you won't fall into that trap, right? And that's the end of section 3.6. Go ahead and work on them. If you get stuck, send me a text, or we'll talk about it in class on Friday. Thanks, and I'll see you next time.